So I was keying this out, the actual test, and I noticed I made a mistake, and it was on this one. So redoing it, obviously. So I did mention that I love this stuff, and I guess I just missed something along the talk while I was doing it. It's just a factoring problem. X squared plus 5x plus 6, it takes an x and x to make x squared. Factors is 6 or 2 and 3, and I know they're 2 and 3 because 2 plus 3 is 5. The bottom factors, again, x and x. Factors of 3 would be 1 and 3. We have to add the 2, so the 3 is positive and the 1 is negative. Now, we're going to change this to multiplication. So, I know that your middle school teachers, they don't use proper math words with you, but to divide by a fraction, we multiply by the reciprocal. Math, in high school math, man, every one of us, it doesn't matter where you go, like we cannot stand the terminology that's being used with you when you're little, and you stick with that little kid mentality and that little kid word, vocabulary. So I'm going to be factoring while I flip, okay, by the reciprocal. That means to flip it. X squared minus 1, it takes an x and an x to create the x squared. 1 times 1 is 1, but there's nothing in the middle, so one of them's negative, one of them's positive. Notice I flipped it. What was the denominator became the numerator. And this guy's going to get moved to the bottom, and it takes an x and an x to create x squared. It takes a 1 and a 2 to multiply together to be 2, and 1 plus 2 is 3. Now, I guess I missed something here, but that piece cancels, obviously, right? I see another one that cancels. That one cancels. This one cancels. There's another one that cancels. That guy's gone too. Now, what we're left with here is essentially 1 times 1. Because when these things cancel, we're saying, when I talk about x plus 2 over x plus 2, when I cancel, I'm saying it's 1. It's like saying 2 over 2 is 1, right? So I'm left with 1 times 1, which is just 1. So yeah, I missed that one. I guess I wasn't paying attention. I don't know. Don't remember. It's a couple days ago and it did. Alright, so here's a problem about a fat cat. So Joe has 3 cats named Amy, Beth, and Meg. She needs to know how much each of them weighs, but they are skittish and will only get on the scale with one of the other cats. She knows that when Amy and Meg weigh together, they weigh 17 pounds. So if I take Amy's weight and Meg's weight and add them together, I get 17. If she takes Amy and Beth together, she gets 19 pounds. And if she takes Meg and Beth together, she gets 22 pounds. There are a lot of ways of solving this particular system. The best way to do it is probably through substitution. I'm going to use substitution. Alright, I'm going to use substitution. So I'm going to take the very first equation right here, and I'm going to solve it for A. So I'm solving it for the cat named Amy. Amy is going to be 17 pounds minus Meg. And then I'm going to take that quantity, and I'm going to plug it in right there. So again, using substitution. That's what it's all about. Alright, so let's see here. Where was I? Oh yeah. I'm replacing that A with 17 minus M. So 17 minus M plus Beth is 19. Subtract 17 from, wait a second. Yeah, we're fine. Subtract 17 from both sides, and I get negative M plus Beth is 2. Now, I did this because I had something in mind from the get-go. Math is kind of like playing chess or checkers. You want to be a couple steps ahead of the game. I take that equation, negative M plus B equals 2, and I've got this third equation that says M plus B equals 22, and suddenly I can use elimination. That was my end goal here. So I start off with substitution, then I go down to elimination. If I just add down, there will be no M's. There are 2 Beths, and together there are 24 pounds. And if I divide by 2, I find that Beth is a 12-pound kitty cat. She's actually a pretty big girl. She is. I mean, look at it. So Beth is 22. That means Meg was 10. which means Amy was 7. Amy's a little bitty one. All right, 18 is going to take some drawing. Good test takers draw. Picture's worth 1,000 words. All that good stuff. Now, I don't expect that you remember this, but the standard form of a circle is x minus h, quantity squared, plus y minus k, quantity squared, and it's equal to the radius squared. It's a simple lineup process. This circle has a center at 3, -4. And you'll swear you didn't see this in geometry. You'll swear you've never seen this. It's you. You saw it. R squared is 25. We only care about the real thing since it's a circle, which means that the radius is 5 units. This is something I can draw. Alright, so right 3 down 4 is the center of the circle, and I need more room actually. I don't need quadrants 1, 2, and 3. There's the center. Now the radius of this thing is 5, so I got to fall 5 units. I've got to go right 5 units. Got to go up 5, be about right there, and I got to go left 5, which would be about right here. And I'm just going to dash this circle. I missed something. I know that it passes through the origin. Let me explain to you how I know that it passes through the origin. I know that it passes through the origin because when I was in geometry, pushing almost 30 years ago, they taught us about 3, 4, 5 right triangles. That circle had a radius of 5. If I go right 3 and down 4 and think about a right triangle, then it's going to hit the origin, okay? Now, it says the line tangent to the circle. Okay, we need to know what a tangent line is. A tangent line touches a circle once and is perpendicular to the center. Okay. That's the definition of a tangent line, straight out of geometry. We like to claim dumb here, like we weren't taught these things. We just didn't care to learn these things. So look at this line right here. This is the line that that goes to the origin. The tangent line is going to touch the circle just once. It's actually going to pass through 0, 0. I know it's perpendicular because by definition it's a tangent line. Plain and simple, it's tangent line. Instead it passed through the origin of the text. Now, this line right here had a slope of fall 4, run 3. The perpendicular slope, which I need from my tangent line, is 3/4. Opposite reciprocals, perpendicular slope, good things like that. And, I can use y equals mx plus b to write the equation. I can use y equals mx plus b. I can use slope-intercept form. The slope is 3/4 of x and plus 0. So just this piece is all that matters because the y-intercept is at 0. Anywho, there is number 18. Moving forward with my life, on to number 19. Two real numbers have both a sum and a product of -6. So if I take two numbers, and I'm just going to call them x and y, and I add them together, I get -6. And also, if I multiply them together, I get -6. Now you're going to get some weird answers here, and you're going to be surprised by that. Some of you will be. A lot of you won't even bother with the bonus questions, even though I'm legit giving you all the answers. You still won't do it, because you're lazy. And, it's my problem, not yours, right? You're perfect. Anyways, I'm going to, for no good reason, solve this equation for y. So y is a -6 minus x. I couldn't do elimination method here. There's no way to add those together and make something disappear. But I can use substitution. And then I'm going to take this quantity and I'm going to put it right there. So it's going to give me x times -6 minus x is -6 We're going to use what we call the distributive property. Negative 6x minus x squared equals negative 6. And we have what's called a quadratic here, and it's got three pieces. It's got x squared, it's got x's, it's got numbers. Anytime you have a quadratic with three pieces, you set it equal to 0. So next line is 0 equals, and I'm actually putting the 0 on the left because I'm going to move stuff to the right to make it positive. You're probably not listening to the audio, or you don't even have the subtitles on. But I moved and shifted to the right to make x squared positive in the hopes that it would factor, and it does not. There are no factors of a negative 6 that will add to be a positive 6. So now I get to sing a little song. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. And we're going to feed that thing. Okay? Don't be the dum-dum that can't figure out what a, b, and c are. Don't be that kid. Every year I see about 10 of them. Every year. It's just amazing. You know, they say the apple doesn't fall far from the tree, but some of y'all, you're the apple and you roll right back to the base of the tree. Good luck growing there. It ain't going to happen. Literally, the tree will suck all the water and nutrients out of the soil. You'll have nothing to eat. And its leaves will block the sun. So there will be no energy harnessed from the sun either. You have to get away from the tree. That's the only way you can prosper. That's why they say that. You have to get away from the tree. Anywho, where was I? Oh yeah, I was ranting. So, opposite of a positive 6 is a negative 6. We are supposed to take that 6 and square it. Then do 4 times a, which is 1, times c, which is negative 6. And it's all sitting pretty over twice a. 2 times a 1. Inside that radical, you got a 6 squared, which is 36. You got a negative times a negative, which is a positive, and 4 times 6 would be 24. So you got a 60 inside that radical. So I want you to go back to Algebra 1 and realize that that's the same thing as the square root of 4 times 15. And the square root of 4 is 2, so 2 roots of 15. Now the reason you can't do that is because you can't multiply and add and subtract. You never bothered learning your multiplication tables. You were supposed to, you chose not to. Maybe it was hard, so you avoided it. You cannot avoid the hard things in life. You have to approach them and you have to conquer them, you have to beat them. If math is hard, beat math. Anyways, back to what we have. We have x equals a negative 6 plus or minus 2 roots of a 15 all over a 2, because 2 times 1 is 2. All three pieces of this thing are even. And every even number in existence is divisible by 2. So negative 3 plus or minus a root of 15. Now, there's actually two answers here. These are the two numbers, okay? One number is negative 3 plus the root of 15, and the other is negative 3 minus root 15. Now, the original context of the question was, what is the value of the larger? Well, that would be that one. And I know that seems funny. You're like, Milbrath, those numbers don't make sense. How can they be true? Because you don't have number sense. So let me show you with the TI-84, which you'll believe over me. You take a negative 3, you add to it the root of 15, and you multiply it by the other answer, which is oddly enough called its conjugate. There's a word we use in here. You multiply it by the negative 3 minus root 15, which again is called the conjugate. And by God, look what you get. Negative 6. Now, if you do the same thing but with the addition step, because remember it had a sum operation. By the way, if you see me using a calculator, you should be paying attention to how I use it. I mean, I've used these things for a long time. Since before you were a sparkle in your daddy's eyes, I've been pushing buttons on a T-84. There we go. That looks right. Still negative 6. There you go. Negative 3 plus root 15 is the big one. And there is the last of the bonuses. Sorry I made a mistake. It happens. I don't ever claim to be perfect. Wish I was sometimes, but I'm not.